Imagine this: before time, before light, before anything, there was nothing. Then, in a fraction of a second, everything exploded into existence. A storm of energy, hotter than anything we can imagine, gave birth to the fabric of reality itself. From that blinding chaos came the first atoms, the first stars, the first galaxies, and eventually us. Every atom in your body was once inside a burning star. Every breath you take is built from the ashes of an ancient universe. But how did nothing become everything? How did the chaos of the Big Bang turn into life, intelligent, curious, and staring back at the stars, asking why? This is the story of how the universe evolved, from a silent void to a living, breathing cosmos, a story written in starlight and still unfolding today. Every story has a beginning. Ours starts 13.8 billion years ago, with nothing, not empty space, not darkness, nothing at all, no atoms, no time, no direction for anything to move. And then, something happened. Something so small, so fast, and so powerful that it created everything that would ever exist. Scientists call it the Big Bang. But it wasn't an explosion in space, it was the sudden expansion of space itself. In less than a trillionth of a second, the universe grew from smaller than an atom to larger than a galaxy. Matter, energy, and time were born in the same instant. Inside this newborn universe, temperatures soared to unimaginable levels, over 1 billion trillion degrees. At that heat, the laws of physics we know today barely applied. For the first few moments, reality was chaos, pure energy swirling and colliding. As the universe expanded, it began to cool. And in that cooling, the first building blocks of everything began to form. Protons, neutrons, electrons, the smallest particles of matter forged out of energy itself. 3 minutes after the Big Bang, just 3 minutes, something remarkable happened. Those tiny particles started to connect, forming the first simple atoms, hydrogen and helium. These elements still make up over 98% of the visible universe today. But at this point, the universe was still dark. There were no stars, no galaxies, only a fog of hot gas stretching in all directions. For nearly 400,000 years, light couldn't travel freely. It was constantly scattered by the thick plasma of particles. Then, the fog began to clear. For the first time, light broke free and traveled across the cosmos. That ancient light is still traveling today. We can see it as the cosmic microwave background, a faint glow that fills the night sky. It's the oldest photograph of our universe, a baby picture frozen in radiation. From there, gravity took the stage. Tiny ripples in that early gas began to pull together, forming dense regions that would one day become stars and galaxies. The universe was beginning to take shape, the first hints of structure emerging from chaos. Every atom in your body, every planet, every star, all of it traces back to that single moment when nothing became everything. This was just the first heartbeat of creation. The next chapter? The birth of the first stars and the beginning of light. After hundreds of millions of years of darkness, the universe was silent but restless. Gravity was quietly at work, pulling, gathering, sculpting invisible clouds of hydrogen and helium into vast clusters. Within these clouds, the first sparks of creation were about to ignite. In the densest pockets of gas, gravity crushed atoms together until temperatures soared above 10 million degrees. And then, a single reaction changed everything. Nuclear fusion, the process that powers every star in the universe, was born. In that instant, darkness ended. The first stars burst to life, flooding the cosmos with light for the very first time. Astronomers call this period the cosmic dawn, the moment the universe woke up. These first stars weren't like the ones we see today. They were giants, hundreds of times larger than our sun, burning hotter, brighter, and shorter lived. Some lived only a few million years before collapsing in massive explosions called supernovae. But in those violent deaths, something beautiful happened. Those supernovae forged the first heavy elements, carbon, oxygen, iron, the ingredients for everything solid and alive. Without those stars dying, there would be no planets, no oceans, no life. We owe our existence to their destruction. As more stars formed and died, they began to gather into massive families, galaxies. Each galaxy became a city of billions of stars, swirling around vast clouds of dust and mysterious dark matter. One of these galaxies, about 9 billion years later, would become our home, the Milky Way. But even as galaxies took shape, the young universe was still wild. They collided, merged, and tore each other apart in cosmic chaos. These galactic collisions helped trigger waves of new star formation, lighting up the universe even more. Meanwhile, something unseen was shaping it all. Dark matter. We can't see it, but we know it's there, acting as the hidden scaffolding of the cosmos. Without dark matter's gravity, galaxies couldn't have formed at all. It's one of the great mysteries scientists are still trying to solve today. By the time the universe was a few billion years old, it had transformed from a formless cloud of gas into a vast web of galaxies stretching across space, each one filled with the light of countless stars. The night sky we see now is a snapshot of that transformation, a silent reminder of how light conquered the darkness. But the story doesn't end there. Because among those billions of stars, one in an ordinary corner of the Milky Way would give rise to something extraordinary, our Sun, and around it, a small, rocky planet that would one day ask how it all began. About 4.6 billion years ago, deep inside one arm of the Milky Way, a giant cloud of gas and dust began to collapse under its own gravity. It was just another patch in the galaxy, unremarkable, invisible, drifting quietly through space. But inside that cloud, something extraordinary was about to happen. As it collapsed, the material at its center grew hotter and denser until, once again, nuclear fusion began. A new star was born, our Sun. Around it, leftover dust and rock began to swirl, forming a massive rotating disk. Inside this disk, tiny grains collided and stuck together, growing into larger and larger chunks, pebbles, then boulders, then worlds. Over millions of years, these collisions gave birth to a family of planets: Mercury, Venus, Earth, Mars, and the giants beyond. But the early solar system was anything but peaceful. Asteroids rained down, worlds crashed together, and chaos ruled the skies. One such collision, between the young Earth and a Mars-sized body, blasted molten rock into orbit. That debris eventually gathered to form our moon. That impact changed everything. It stabilized Earth's tilt, giving us seasons. It slowed our rotation, making days longer, and it may have helped shape the conditions that made life possible. In those early days, Earth was a dangerous world. Volcanoes, lightning, and a constant bombardment of asteroids. But it was also rich in chemistry. Oceans formed, minerals reacted, and somewhere in that vast, churning mix, life sparked for the first time. We still don't know exactly how. Maybe it began in deep-sea vents where heat and minerals fueled complex reactions. Or maybe it rode here on comets, frozen seeds of life scattered across the cosmos. Either way, from those first microscopic cells came everything: plants, animals, and eventually, us. Every breath you take carries atoms forged in ancient stars. Every cell in your body is built from elements created in explosions billions of years before Earth even existed. You are not just part of the universe. You are the universe, made self-aware. From nothing came everything. From chaos came order. From stardust came life that could look up and ask, where did we come from? And that question, that spark of curiosity, is perhaps the universe's most beautiful creation of all.